Alrighty, y'all. So here we go. So for number one on this, they're going to let f of x equal x minus 1. G of x is going to equal x squared plus 2. So for this one, they want us to find f composed g of 7. So this was the composition stuff we did in 9.1. So remember, when they use this terminology, it really means f of g of 7. So what we're going to do, we're going to start with g of 7 first. Once we find g of 7, we'll put that into our f function and get our final answer. So always start with the innermost function, okay? Especially when they give you numbers. So for g of 7, we're going to take this g function and put a 7 in for the x. So that's going to give me 7 squared plus 2. All right, so working this out, I will do my exponent first. So 7 times 7 would be 49 plus 2, which gives us 51. So since g of 7 is 51, we now put this into the f of x. So that means we're finding f of 51. So that 51 goes right into the f, okay? So putting a 51 in for the x, I'm going to have 51 minus 1. Right? 51 minus 1, that's what we got. And then 51 minus 1 gives us 50. Final answer. Okay, so number one, they're going to give you a number to find. And like I said, you find the innermost function, get that answer, put it into the f, okay? Now, 2 and 3 are going to be doing the same thing, except they're not giving me numbers to put into it. And then at the end of these ones, we're going to find the domains. So these ones, we're going to find f composed g of x, g composed f of x, and the domain of each. Okay, so we'll start out doing f of g, g of f. Once we got them two, we'll find their domains, okay? So for this problem, f of x is going to equal x plus 17. G of x will equal x minus 17. All right, y'all, so let me start with f composed g of x. Remember, that's like f of g of x, just like that problem I did up here. Which means we're going to put g of x into the f function. Since we don't have any numbers, we can't do anything to the g of x. It's going to stay x minus 17. So what we're going to do is put this whole thing into the x's on the f. Okay? So here we go. F composed g of x. So you're going to take the f function and put the x minus 17 in for the x. So that's going to give us x minus 17. That's the x. And then we got a plus 17. And y'all remember this one is the one where these canceled. So our final answer will be x. Okay, so the numbers cancel and we're only left with the x on that one. So f composed g of x equals x. So let's do g compose f of x. Now remember, g compose f of x is really g of f of x. So this time we're taking the f of x, which is x plus 17. We're going to take the x plus 17 and put it into the x for the g. So here we go. So take the x plus 17, put it in for the x. And then at the end, we still got a minus 17. And y'all look at that. Once again, those cancel. And I'm only left with a x on that one. So number 2, you pretty much get x's on it, okay? So now let me do the domain for the first one. And they always want domains in interval notations. So, do you see any numbers you might have to exclude from this first function? X minus 17 plus 17. Are there any numbers y'all would exclude from that domain? And y'all, if you remember, when I'm looking at domains, I'm looking at fractions. And y'all, x minus 17 plus 17 does not have a fraction 1 in it. So since there's no fractions in the first function, it's good from negative infinity to a positive infinity. Mhm. So let me look at this one. Well, y'all, x plus 17 minus 17, there's no way to get this undefined because I do not have a fraction with a variable in the bottom again. So since there's no fractions with a variable in the denominator, there's no numbers I need to exclude from the domain. So once again, this domain will work from negative infinity to a positive infinity. All right, y'all. So now we'll get into the same type problem as this, but this next one, we will have numbers to exclude from the domain on it. And we're doing the same thing. We're going to find f compose g of x, g compose f of x, and the domain of each. All right, y'all, but look what they're giving me this time. They're giving me f of x equals 2 over 1 minus 7x. And then my g of x, they're giving me 1 over x. So we had a homework problem just like this one also. Okay, and we did have places to really worry about the domain on this one. So I'm going to start out with f compose g of x, which we said was like f of g of x. So since the g of x is the innermost function, we're going to take this g of x, 1 over x, and put in to the x on the f function. Okay? Alrighty, y'all. So here we go. All right, so f of x is 2 over 1 minus 7 times my x, and my x is 1 over x. All right, so let me simplify this a little bit. Bring down that 2 on top. And then on bottom, I get 1 minus. So what I would do first is multiply 7 times 1 over x. And remember, treat the 7 like it's got a 1 under it so that you multiply straight across. So on top, 7 times 1 is 7. On bottom, 1 times x is x. All right, y'all. So this was the one when I said you had to simplify it because this one has a little fraction inside of a big fraction. And we're not allowed to leave it that way. So on this one, what you want to do, since your fraction has a denominator of an x in here, we want to multiply all 3 parts of this by x. So that's going to be 2 times x on top 1 times x on the bottom minus my 7 over x times x. So all three of these parts have to be multiplied by that x. All right, also on top, 2 times x is 2x. On bottom, 1 times x is x minus, and y'all here, the reason I multiplied by x was so I could do that right there. Cancel them x's out. All that's left is the 7. So in a second, when we look at the domain, at this point, since this x is in the denominator, this x at the moment cannot equal 0. So we'll exclude 0 from the domain in a second. And then down here, you got an x in a denominator. At this point, that x right there cannot equal a positive 7. Okay, because if that was a 7, 7 minus 7 would make that 0, okay? So this is what it's simplified to. And then when we do the domain, we'll kick out a 0 for that x and a 7 for that x, okay? All right, so next we had to do g compose f of x, which is really g of f of x. So this time I'll put the f of x into the x on the g, okay? All right, y'all, so here we go. So g is 1 over x, so that's going to be 1 over. All right, so it's 1 over x, but remember my x is this whole function. 2 over 1 minus 7x. All right, so in a little bit, we're going to figure out what this x cannot equal right here, because it's in the denominator of the fraction, right? So we'll find out what that x cannot equal in just a second. So on this one, you got 1 divided by another fraction. We can't have this fraction inside of our main fraction. So what I'm going to do this time, since this is my denominator, I'm going to multiply the bottom and top by that 1 minus 7x. So that's going to give me 1 times 1 minus 7x over 2 divided by 1 minus 7x times 1 minus 7x. Just remember, what you do to the top of a fraction, you do to the bottom and vice versa. Now, the reason I did that was because this small fraction on the bottom, the 1 minus 7x's will cancel and they're gone. So on top, 1 times 1 minus 7x will give you 1 minus 7x. On bottom, since the 1 minus 7x is canceled, all that's left is our 2. And that will not simplify any further. So, since this is 1 minus 7x, the only number this x cannot be, x cannot equal a 1 over 7. Because if x was 1 over 7, the 7's would cancel, and you would have 1 minus 1, which would make that a 0. So, if your number's like mine, a 7, then the x cannot equal a 1/7. If you have a 5 here, then it's going to be a 1/5. A 3 here, then it would be 1/3, okay? Your fraction will match your number out front under a 1. All right, so this is what it wanted for f of g of x. This is what it wanted for g of f of x. Now we got to do the domains. Now remember, on this one, I said x could not equal 0, x could not equal 7. So your domain will go from negative infinity to 0 union around 0 to 7, union around 7 to positive infinity. So you had to kick out two numbers. You got two unions on this one. Over here, all I got to do is kick out the 1/7. So my domain will go from negative infinity to the 1/7, union the 1/7 to a positive infinity. Okay, y'all, and then on that one, they actually do like an A, B, C, D answer on that one. All righty, y'all. So number 4, we're going to go to Math Lab and look at how they got number 4. All right, so make this just a little larger. So the question was using the horizontal line test. So they're telling you to use a horizontal line. Determine if this is 1-to-1. And what y'all got going on? Because if it's 1-to-1, listen, you're right? You got no. Because remember, horizontal lines test said if it's possible for a horizontal line to intersect a graph more than once, then the graph is not 1-to-1. So on that one, you would put a no and move on. Okay. All righty, back to number 5. All righty, also for my number 5 here, for the following function, we're going to determine if 1-to-1. So determine if 1-to-1. If it's 1-to-1, find the inverse. Right, they're giving me f of x equals x plus 2. Now, I'm going to tell you all a little trick on this one. They're all going to be 1-to-1. This is a straight line and it should be going uphill to the right, but it's definitely 1-to-1. And you can actually graph them if you want to. Um, and you'll see that it's just a straight line. But y'all, everybody's number 5 will be 1-to-1. So you'll click the blank that says yes, 1-to-1, and then you're going to put in the inverse. Now, since I'm finding the inverse, this is where I made the f of x into a y. And y'all, let me ask y'all this. To find the inverse, what was my next step on that problem? Because I made the f of x into a y, and then this next step was the main one in finding the inverses. Flip the x and y, perfect. You're going to put the x out here, and that's going to equal to y plus 2. All right, then the only thing left is to solve for the y. So to get that y by itself, we subtract 2 from both sides. So we get x minus 2 equals y. Now remember, MathLab will have this written down for you. Inverse notation lets me know that this is the inverse function that I just found. And that's going to equal the x minus 2. And all you're putting in is the part in the box, okay? So, yes, they're all going to be 1-to-1, and then you find that inverse. Number 6 is the same thing. Determine if 1-to-1, if 1-to-1, find the inverse. So this one I said was a straight graph going uphill like a line. This one, let me draw the function, is f of x equals a square root x plus 3. Um, so if you was to draw the square root one, it was the one that went uphill to the right really slow. But it is 1-to-1, okay? It's just a slowly uphill graph. But I will say it's going to be 1-to-1. So we're going to do the same thing. Switch the f of x with the y. Switch the x and y so that we get x equals square root y plus 3. Now this is the problem where I couldn't move the 3. You can't subtract 3 from both sides because that 3 is under this square root. So your first move would be to get rid of that square root. So this is where I said, well, to get rid of square roots, we're going to square both sides. So we're going to square the x, and then that's going to equal the square root of the y plus 3 squared. All right, so let's see what that's doing. Bringing down our x squared. Over here, the radical and the exponent cancel, leaving the y plus 3. And then, y'all, my last step is to subtract 3 from both sides. I get x squared minus 3 equals y. So then they're going to give you the f inverse of x notation. And that's going to equal x squared minus 3. Now this one, since x squared is a parabola, at the end of this answer, it'll say x has to be greater than or equal to 0. So you want the one that looks just like this, okay? And they'll have an A, B, C, D answer on that one also, okay? All right, y'all, then we get into graphing. So let me go to Math Lab and see what they got for number 7 here. So they want us to graph the equation on paper and choose the correct graph. Now that is y equals 6 to the x. That's an exponential graph, okay? And the exponential graphs always had one shape where they sort of went to the right and then uphill. So y equals 6 to the x, that can be knocked out really quick on our calculator. So let me go to y equals, put in 6 exponent x. And y'all, let me graph it and see what we get. All right, so I'm going to set my window back to a -10 and 10. So the easiest way to do that is to hit zoom and 6 for standard. All right, y'all, so you see what it's doing. It's coming along the x-axis and then it curves uphill. So the one I want is the one that curves uphill. And y'all, that's going to be B up here. All the exponential graphs are going to look like B. A is just a straight line. C graph is the logarithmic graph is what C is. And D over here, that U-shaped, is like our parabolas for the x squareds. So the only one it could be would be B on that one, okay? All right, y'all, number 7 was one where we had to, what is this, number 8 was the one where you had to figure out what moves it was doing and then graph it. So for this one, start with the graph of y equals blank to the x. In that box, what are we putting? 2, good job. Because that's your base of your, you got a 2 to the x plus 5, so your base is 2. Now we're going to shift it blank 5 units. That 5 is being added to the exponent of x. So let's see what y'all pick here. Shift it blank 5 units. Down, right, left, or up. And when you're attacking the exponent, it was sort of like the ones where they were in the parentheses. If they were positive, it moved left. Oh, Destin, you got that. Good job. You said left. Okay. So if it's positive, it's going left on the exponent. If it's negative, it'll go right for the exponent. And then at the end, it says shift it blank 4 units. Up, right, left, or down. So they're subtracting 4 from the end of it. So that's going to go down, y'all say. There you go. So at the end, if they add, it's up. If they subtract, it's down, okay? All right, now, y'all, here's the trick, is the graph. So you're going to go to the second row and the second tool. It says exponential tool. Click that and then click anywhere on the graph. The first thing I'm going to do in the bottom left, it says base inside that box. They got an E. You got to change that E to match the base of your problem. So for me, the base needs to be a 2. All right, you said left 5 units. So take that horizontal shift and go left to -5. Then y'all said down 4 units. So take that vertical shift and go left to -4. Now my graph has moved left and down. So at that point, I'm going to save that and be ready to move on, okay? But y'all, the most important thing on that problem is to make sure you change that base. Hey, let's see, ninth birthday. Oh, this one's about the little girl with the birthday. So on Melissa's 6th birthday, she gets a $5,000 CD that earns 5% interest, compounded semi-annually. Okay, so $5,000 certificate of deposit at 5% interest, compounded semi-annually. If the CD matures on her 16th birthday, how much money will be available? Okay, so this one I gave you a formula. Remember, it was A of T. The amount in the account at any time T equaled P, which was my principal balance, times 1 plus R divided by N, all raised to the N times T. So we just got to fill in everything we know, punch it up, and we'll get the amount. First off, what was the time? How many years went by between her 6th birthday and her 16th? So good job, that'd be 10, right? So T equaled 16 minus 6, which was 10 years. So I know what the T is. P. So let's start this out. We're going to be finding A of 10 years. That's going to equal P. So what are y'all putting for P? And remember, P is your starting amount. Y'all got that over there, 5,000. Good job. Times 1 plus R. R is my interest rate. That's 5%. What is 5%? That's what, a 0.05? Yeah, because see, the decimal's after the 5. You moved it left once, moved it left twice. So you had to add a 0, and that's going to give you a 0 technically, 0.05. So that 0.05 goes on top. Just remember, 5% is like a nickel. 10% would be zero point 0.1 like a dime. 7% would be 0.07 like 7 cents and so forth, okay? All right, y'all, on the bottom is the N. N is the number of compounds. So if you're compounded semi-annually, how many did I say that equaled? So that's going to be 2. So you got a 2 on the bottom. And then the exponent will be NT, which will be 2 times 10 for the 10 years, okay? So the bottom of the fraction and then the first number of the exponent are 2, and then that's T, which is time. Now, we're rounding it to the nearest cents. So we're looking at 2 decimal places on this, okay? All right, so I'm just going to go to the calculator. I got 5,000, parentheses, 1 plus. If you want this to look like a fraction, hit alpha y equals enter. On top was 0.05. Arrow down to the bottom, that was a 2. Arrow right, close those parentheses, and then do the exponent, which was 2 times 10. And y'all, that's what's nice about these TI-84s. You can make this problem look exactly like you got it written on your paper. All right, now she better have more than 5,000 because that's what we started with. So if you get anything less than 5,000, you definitely made a mistake, okay? Because this is an investment, so it should grow. All right, 2 decimal places. I got a 81. I got 8,193. Point. All right, no, that's a 0.08. The 8 has a 2 after it. So I'll keep that a 0.08. And that's a trick on that when getting your formula written out and then just putting everything where it went. Principal balance, your starting amount, your interest rate as a decimal, your number of compounds, and then the number of compounds times the number of years that went by, okay? All right, y'all, find the logarithm. I got a log base 10 of a 0.01. So y'all push that in and get me an answer. You got to remember the log on the front of your calculator is the log base 10. So you could use the one on the front or you could use that log base. Either way, don't matter. But me usually if it's a log or a log base 10, I use the one on the front. It looks like y'all got it right up. What y'all got? -2. Looks good. So that one I could have just did what? Log 0.01 enter. And y'all, you get a -2, okay? All right, 11 is where we started converting between logarithmic and exponential. So 11 says convert to logarithmic equation. And they're giving me Q to the M equals 36. Okay, so this is where I'm doing this kind of stuff. Log base A of y equals x if and only if A to the x equals y. So this one, we're starting on this side and we're going to rewrite it like this. So we write log. The base of the log is the same as the base of the exponential, which is the q. So I'll come down with my q. Next, y. Well, y is equal to the result of the exponential, which is 36. And that's going to equal x. Well, x is the exponent of m. Okay, so that one you're just rewriting. 12, we're going the other way. This one we converted to logarithmic. 12, we're going to convert to exponential. So let me see what they gave me. They gave me a log 0.0001 equals -4. I'm still using this, but now they're giving me the left side, and I got to convert it to the exponential side. Oh, so what would I put for the base since there's no number down here? All right, McKinney, that'd be a 10. So my base is a 10. And then I'm looking for my exponent. Well, the exponent was x here, which is equal to this -4 here. And then 10 to the -4 is going to equal y. Well, y was the number after the log. So that's going to be 0.0001. All righty. 13 wants you to use a calculator. Now, here's where they get people. They want you to round it 4 decimal places. Usually on the logarithm stuff, they're going to have you round 4 decimal places, okay? And they're giving me a log of 4. So I'm going to use curvy equals because we're rounding it off now. Um, so do y'all want to try that? Log 4, you can punch that right on the front of your calculator. And we're going to round it 4 decimal places. So let's go to a calculator. So let's see, Justin's 0.6021. So y'all, let's see if they're right there. I'm gonna pull my calculator up, clear everything off. And that was a log of 4, enter. And y'all look at that, 0.602. Good job, you made that 0 a 1 because the zero's in the 4th spot, but it has a 5 after it. And if it's 5 or bigger after it, you round up. So good job, that is definitely 0.6021. Okay, y'all, so when you're rounding off, you do gotta round up or leave it the same based on that 5th number, okay? All right, y'all, then we're going to start getting into the logarithm properties. So this is what, 14? So for 14, we're going to express as a product. Now, when it says express as a product, all you're doing is bringing the exponent down to the front and rewriting it as a product, okay? So they're going to give you something like this. Log base m of t to the 17. Now they've got this in parentheses, but it don't matter. They're just sort of separating stuff. But to rewrite this as a product, you're going to bring the exponent down to the front and make this 17 times the log m of t. Now remember, if they use capital letters, you got to use capital letters. If they use small letters, you got to use small letters. But all you're doing is bringing the exponent down to the front and writing it as this product. So basically, one move on that problem, okay? All right, 15 says rewrite as sums or differences. Sums or differences, so they're giving me ln of x to the fourth, y to the sixth times z. So since these are being multiplied, we will rewrite it as a sum. So this says sums or differences. So it don't mean you're going to have both. You're going to have one or the other. So since these are being multiplied, it's going to be sums. So distribute the ln to everybody. Ln of x to the fourth plus ln of y to the sixth plus ln of z. Now, y'all listen here. Although that is rewritten as sums, you still got one more move to do to this before they consider it simplified all the way. And that goes back to this product rule here, this power rule we did. I got exponents on two of these. We got to bring those exponents down and rewrite each of those as a product. So this one will give me a 4 times ln of x. Plus this one will give me a 6 times the ln of y. Plus at the end, there's nothing I can do. So leave that ln of z. This is what MathLab wants for that answer, okay? You got to bring the exponents down. All right, y'all, this number 16, I mean, express as a single log. And then, if possible, simplify. Well, anytime they say this, if possible, simplify, you're probably going to simplify it, okay? So let's start out what they're giving us. Log 10,000 minus a log of 10. So they're giving me subtraction. So when I rewrite stuff that's a difference, it's written as a quotient. So this will be log 10,000. And remember, the part always being subtracted went to the bottom. So that went to the bottom. Now, 10,000 divided by 10 leaves me 1,000. So that's the first answer it wanted, to be written as a single log. But this one simplifies further. So y'all punch this on your calculator and tell me, what does a log of 1,000 further simplify to? 3, perfect. So this number 16 has two answer blanks, once for the simplified logarithm and then once for the simplified answer, okay? Y'all. 17 says to simplify. Simplify the expression. All right, they're giving me a ln of x squared plus 14x plus 45 minus ln x plus 9. So basically, I'll do to this one what I did to the one with the numbers here. I'll rewrite it as a single logarithm first, and since it's being subtracted, it's going to look like a quotient. So y'all, both of these are ln's, so bring out the ln. On top will be the x squared plus 14x plus 45. Once again, the stuff being subtracted goes to the bottom, so that'll be the x plus 9. All right, y'all, so this is the one where you got to factor the top to see if you can cancel anything out. So the bottom's going to stay x plus 9. Nothing you can do to the bottom. On top, x squared is x and an x. All right, watch this. This last number's positive. Since this last number's positive, both of these factors will be positive like that middle number. Can y'all find me factors of 45 that'll add to get a 14? So let's see, 45 is 1 and 45, 3 and 15, and then 5 and 9. All right, Jason, you got them 9 and 5. Perfect. And y'all, it has to be a 9 because if you don't get a 9 up here, you're not going to be able to cancel these because these things cancel out. And your final answer is the ln of x plus 5. On this problem, you must keep the parentheses. You got to keep the parentheses on this problem, okay? All right, y'all, so that's a little bit of going through some of them logarithm properties we did, okay? So next, looks like we're going to be solving equations. All right, y'all, let's knock out, what are we on, 18? 18 says, solve for x. After giving me 5 to the 8x minus 3 equals 25. So this was the new stuff from yesterday. This is an exponential equation. So my first step was, can I rewrite each side using the same base? So y'all, is it possible on this one to rewrite both sides? And that's definitely a yes. Good job. So bring down this side, 5 to the 8x minus 3. That's going to equal 5. Well, y'all, how many 5s does it take to multiply to get a 25? It takes 2. There you go. So this is where we said, oh, our bases match. Since our bases match, the base exponent property says that these got to be equal. So 8x minus 3 has to equal that 2. And at this point, it's just a matter of solving for x. You're going to add 3 and then eventually divide by that 8, okay? So add our 3 to both sides. I'm going to get my 8x. That cancels. 2 and 3 gives me 5. And then divide both sides by 8. Well, that cancels, giving me a 1x. And y'all, there's nothing I can do to that, so that's going to stay 5/8. Alrighty, 19. Same thing, solve for x. I got log x equals -1. So on a logarithmic equation, I don't have a log base equal to a log base. I don't have more than one log on either side. So since I just got log equal to a number, I'm going to rewrite this one as exponential. So y'all, the first thing I need is what's my base? Because if I'm rewriting it from log to exponential, I need a base here. But there's not a number shown. So it's going to be a 10. Exponent is going to be that -1. And 10 to the -1 is going to equal that x. So y'all, to finish this out, we got to figure out what 10 to the -1 equals. So I'll just go punch that on the calculator real quick. So 10 exponent. I think y'all got what, a 0.1 there? That looks good, Jesslyn. Because when I punch it in, I get that 0.1 just like you. So that equaled 0.1 equals x. So I'll tell you the trick on these. If it's a 1, you get a 0.1. If that was a -2, that would be moved over again and make that a 0.02. If that's a 3, it'd be 0.001 and so forth. All right, it looks like we got one more problem, y'all. Now, number 20 deals with the continuous compounding problem that I did yesterday from 9-7. So they're telling me that 12,225 is invested at 6.3% per year, compounded continuously. So since it's continuously, we can't use the formula a while ago where I had the A times the 1 plus R over N. That formula won't work on this one. For this one, we're going to use the formula P of T equaled P initial times E to the KT. Same thing. P initial is my starting amount. K was my growth rate or my interest rate. T was my time in years, okay? All right, so the first thing, this one has an A, B, C. A, find the exponential function. That describes the amount in the account after T years. Well, they're going to give you the P of T part, and we got to figure out the rest. So P initial, my initial amount, that's 12,225 times E. All right, we need K. Now remember, K is 6.3%, but I need y'all to move that decimal left twice, and that's going to give us a 0.063. So that's 0.063 times P. So if you know how many years went by, you can find your amount in that account, okay? So y'all, for A, this is what MathLab wants. Just the formula. Right, then B, find the balance after t equals 1, 2, 5, and 10 years. All right, so I'll do t equals 1, t equals 2, t equals 5, and then t equaled 10. Now let's see, on these, we're going to be rounding these all to decimal places. So I'm going to go to calculator. I'm going to put a 1 in for the t, figure out what I get. And then a 2, a 5, and a 10, okay? I'll get them four amounts and then I'll come put them all in. So I'm going to clear everything off here. All right, so for t equals 1, I got 12,225. Second ln to get the e with the exponent. And then that's 0.063 times 1. All right, so that's my first one I get. I get 1,000. Well, woo, that's $13,019, and two decimal places will be 9.5, and I'm gonna keep that a 5 since it's got a 3 after it. So that'll be a 0.95. All right, then I would do the same thing. 12,225. Second ln to get the e. 0.063 times 2. So when I do that one, I get $13,866. Now that's a 5-9 with a 9 after it. So I'm going to round that 9 up into a 10, which means I'm carrying a 1 to the 5. So 59.9 will round up to a 0.60. All righty, y'all. Next, 12,225. Second ln 0.063 times 5. Enter. So that one I'm getting 16,751.42 because that 2 has a 0 after it. All right, then finally, 10 years. I got 12,225. Second ln 0.063 times 10. All right, so let's see how much they got after 10 years. They got $22,953. And let's see, that's a 0.78, but the 8 has a 9 after it, so I'll make that a 0.79. And y'all, that's a trick on them, just changing t every time because t is how many years went by. So they started with 12,200. After 10 years, they made about 10,000 at that interest rate, okay? All righty, now what was C? C wants the doubling time. The doubling time is blank years. All right, so doubling time was where I said the capital T equals the ln of 2 divided by your K. So that's going to be the ln of 2. Our K up here was at 0.063. So I'll tell you all a trick. If you ever want to know, if you ever make an investment and you want to know how long it takes to double it, you always do this. ln of 2 over your interest rate, okay? All right, we're going to do this one decimal place. So y'all, let's go punch that out one decimal place and see what we get. So alpha y equals enter if you want it to look like a fraction. On top, I had an ln of 2, close parentheses. On bottom, 0.063. Now, I do know this needs to be more than 10 years, because remember, 10 years, my investment went from 12,000 to around 22,000 something. So that's not quite double. So this answer better be greater than 10, okay? So when we hit enter, I get 11.00. Well, they only wanted me to go one decimal place. So that would be 11.0. Right, y'all. So the doubling time here is where you would put 11.0. Gotta keep that decimal point on that one, okay? All right, y'all. Questions on that? That's pretty much module 4. Be careful, like I said, when you're graphing, the one where you're moving it, change that base from an E to whatever number your base is, okay? And y'all remember, after you take these tests, look at what you missed, because if you accidentally put a space in or an extra comma or something, I can look at those and give y'all credit on those, okay? Um, like on this one, where we was doing the LN stuff, remember that's a little L and a little N. That is not a capital I and an N, okay? That is a LN on those. So on the quiz review, y'all remember quizzes are actually 15% of your grade. Um, and they're just like the test. So go on and do them reviews because we want y'all to do that and get a good grade before you even do the test. But yeah, they're like 15%. So at the end of the year, which will be Thursday, after y'all taking your final exam, that's when I'll go in and I'll replace your low test grade with your final exam grade. If it's higher, I'll go in and I'll drop 2 low homework grades and I'm going to drop 1 low quiz grade. So at the end of everything, I will drop those assignments, okay, from your grade. So if you got a 0 in one of your quizzes or a 0 on one of your homeworks and stuff, those are going to drop out and not affect your grade, okay? Alrighty, y'all. So, ooh, that didn't take very long at all, just an hour. So y'all let me have any questions y'all got. Because tomorrow, what we're going to do tomorrow